Okay, sorry about that. I'm making a second video because I ran out of storage when I was making the first video, so I had to delete some files. Anyway, so I left off in the last video doing 68 1/2 times 2. So 68 times 2 is 136, then add the 1 in the numerator, you get 137, and keep the same denominator 2, then multiply by 2. You can make that 2 over 1 if that helps you, but 2 on top cancels out with 2 on the bottom to get 137. So x equals 137. Okay, but it's not always going to come out so cleanly like it did in this problem. So let's practice the cross products method, which works in all situations when you have equal fractions. So multiply the diagonals and make them equal to each other. So that's going to be 68 1/2 times 6 equals x times 3, which is 3x. And since we're multiplying, we need to convert that mixed number into an improper fraction, which we already saw over here is 137 over 2. Then times 6 equals 3x. You can cancel out 6 on top with 2 on the bottom, because each of those can be divided by 2 to get 3 and 1. So 137 times 3, let's work that out. 3 times 7 is 21, carry the 2. 3 times 3 is 9, plus 2 is 11. 3 times 1 is 3, plus 1 is 4. So we get 411 equals 3x. Then divide each side by 3. The 3's cancel out. 411 divided by 3, we could work that out, but we know it equals 137 because we just did 137 times 3 is 411. So x equals 137. Or actually what we could have done was divide each side by 3 over here to cancel out the 3 on each side to get x equals 137 immediately. Okay, example 2. So we have similar triangles. Let's set up a proportion to find the missing length. So here are the triangles. All right, so the length of this line segment is 2 centimeters. And then 1.5 centimeters, 2.5 centimeters, 3 centimeters. And then this entire length here is 10 centimeters. For that entire side of the biggest triangle. All right, so let's find x. And x is here. Okay, so we have similar triangles. As you can see, the small triangle on top is just a small version of the entire large triangle. Otherwise, they're the same shape. So let's set up a proportion to solve for x. So let's set up equal ratios of corresponding sides, matching sides. So we have x And then the corresponding or matching side to x in the small triangle is 1.5. Okay, and now we need to do 10 over 2.5. Because notice 10 centimeters and 2.5 centimeters, those are corresponding or matching sides in the big triangle and the small triangle on top. And notice I was consistent. I had big triangle values on top for both fractions, and I had small triangle values on the bottom in both fractions. Okay, let's go ahead and solve this. So let's use the cross products method. Multiply the diagonals and make them equal to each other. X times 2.5 is 2.5x. And then we have 1.5 times 10. 1.5 times 10 is 15. Because the shortcut for multiplying by 10 is to move the decimal point one place to the right, since 10 is 1 with 1 0. And then divide each side by 2.5. The 2.5s cancel out. And let's work that out. 15 divided by 2.5. Always put the top number on the inside and the bottom number on the outside of the box. The number on the outside cannot be a decimal number, so move the decimal point to the end of the number, one place to the right. To balance it out, do the same thing for the other number. There is no decimal point, so put it at the end of the number and put as many zeros as you need after the decimal point. Move it one place to the right. So we have 150 divided by 25, which is 6. Because 25 times 6 is 150. So x equals 150. So that cross products method works for all situations. A shortcut for this particular problem would have been to notice that 2.5 goes into 10 4 times. So yeah, 2.5 times 4 is 10. And since these are equal fractions, the bottom number of the first fraction must also be multiplied by 4 to get the top number in the first fraction. And 1.5 times 4, let's work that out. 4 times 5 is 20, carry the 2. 6, there's one decimal place in the multiplication problem, so we need one decimal place in the answer, so 6.0, which is 6.